Okay, today I did something that I've been wanting to do for quite a while. I made one of these Joule Thieves, and I've been wanting to do this for a long time. This was designed by a man named Z. Kaepernick in 1999. It was posted in Everyday Practical Electronics, and it's an extremely simple little, basically inverter circuit using one transistor and an LED. And it drains the last bit of juice out of a AA battery and runs an LED for a long time. And it's very, very similar to a Bedini circuit. They're using back EMF basically to light that LED. A lot of guys are doing this circuit and playing with it, so it was my turn today. It is an extremely simple circuit. It uses a little NPN transistor. This coil is 20 turns, 20 turns at the bifilar on a little ferrite core, hollow core. And just Google Joule Thief, and the instructions are online on how to make this. I highly recommend everybody who's playing with back EMF or Bedini circuits or the Peter Linderman circuits, make one of these and study it. It's very interesting. It's very simple, really easy to do, and then you can modify it and do things with it. And Kubikop, I believe that's how it's pronounced, figured out a way to take this and turn it into a charger. And I decided to do the same thing. So I made a charger circuit out of it. And what I did, it's basically the same Bedini kind of idea. You come off the collector on back EMF, and you go into a battery or a capacitor. You take the negative side of it, you plug that right back into the positive side of the source, and you end up charging on the back end on this back EMF at a higher voltage than what's coming out the front end. It's a phenomenal effect, but it does work. Now I left in the LEDs here just to show you how this works, and that's the little bifilar coil. I also added a potentiometer here to control the voltage going into the base of this transistor. This is a little 2N222 like I've been using on the other circuits. And anyway, a real fun little project. I had a lot of fun doing this today, but this is basically like a breadboard setup here. And what I've got is on the far left, you'll see the red meter. That's my drive or source battery. It's a 1 AA rechargeable. It's like 1.3 volts. On the first sheet of paper there is basically the circuit, the Joule Thief circuit. On the right hand side, the yellow meter is the charge part that I added. That's this part over here. And I've put a capacitor in here just to show you the voltage climb on the back side of this. And then I'll show you what happens on these charge batteries. And there's 2 AA's on this side. There's 1 AA on that side. And I will show you how you can actually take the energy out of that battery, bump it up with this circuit, run it through the system, and actually charge basically a larger battery with a smaller battery. Okay, this is the voltage on the capacitor right here right now. It's 0. I have that dialed out to 0. I don't have the batteries connected right now. That's not connected. I'm going to show you what happens on that capacitor when I run the system. I've got a couple of LEDs here. I'm going to show you how I light those up if I want to right here. But I'm going to run the system without the LEDs on right now. This is battery voltage on the drive. Let me connect it now. Pan over here real quick. Okay, there goes voltage on that cap. She's climbing right on up. There's voltage on the drive, the source. Now I'm going to connect this charge battery here before this gets too high. Okay, now that's now going into those 2 little batteries right there. This is my source battery, 1.3 volts. I've got voltage and amperage actually going into these batteries here. Now with my potentiometer right here, I can dial up more power. Now I'm going to show you here that it's going to climb. If I dial this up more power, there goes more power going into these batteries here on this side here. Now that's costing me some on that side. It's just like a Bedini. You have to find the sweet spot and let this thing run. But yeah, this is a charging circuit now on this Joule Thief circuit. Now on the lights, I'll just connect the lights here and show you the lights. You can connect the lights too. And there's the LEDs going on. And with my potentiometer here, I can vary the intensity of the lights too. They go up and down also. This isn't going to show on the camera very well because the camera averages out the luminosity, so it's hard to show brightness on this camera. But yeah, this was a fun little project today. I got a big bang out of this one. It's such a simple little thing. It's just this one little 2N22, and you can get a package of these at Radio Shack for less than $3, a package of 15 of them. This is a part from Radio Shack. You can get a couple of those for less than $3. And then it's 20 turns, two coils of 20 turns each. And it runs through this little transistor and then a resistance here on the base. And then it goes to the LEDs in the normal Joule Thief circuit. And then I spin off of that, go through a diode, and now I've got a charging circuit out of it. You can see how the voltage is going up on the charge batteries. But this is something that this got a lot of potential. I think a lot of the guys that are playing around with this have the right idea. I've been seeing more and more of this on the forums. They're taking this Joule Thief circuit and working with it, and I think it's a real good idea. Excellent project for a beginner. It doesn't take very long to build. It's rather simple and pretty foolproof. I didn't have any trouble getting this to work right off the get-go. Anyway, that's the latest. The Joule Thief charger.